For geometric series, let's just dive right into the formula. So S sub n represents the sum of n terms, just like it does for an arithmetic series. So the sum of n terms. And then in here, n would be the number of terms we're finding the sum of. U1 is our first term. And then r is our common ratio, which we talked about when we did geometric sequences. So the reason why this works is if we look at an expansion of a geometric series, all of them always have u1, all of the terms. So we can factor out a u1, and we'd be left with 1 plus r squared, and that would continue on until we get r to whatever power. And then this is actually just a really well-known polynomial, and it's known that if I take r to the n minus 1 and divide it by r minus 1, I get this polynomial. So not as cool of a proof as it is with arithmetic series and sequences, but there's lots of information out there on how this polynomial is derived. So let's do a couple of examples. I have the formula up here for us to refer to as we go through them. So for the geometric series, and it goes to the 8th term, we want to find the sum. So our u1 is just our first term, which is given as 200. We're going to need to find r. So just like with sequences, to find r, we do that by taking our second term divided by our first term. So that comes out to 1/2. And then n, as I said before, we're going to the 8th term, so n is going to be 8. So the sum to 8 terms would be 200 times 1 minus 1/2 to the 8th over 1 minus 1/2. And then from here, we're just plugging into the calculator. So the sum ends up being 398.4375. And that is it. Okay. So for this one's given in sigma notation. So let's go through again to find all of our pieces. To find the first term, we can do that just by plugging in 1 into the equation. So my first term would be -4 times 3 to the first, which is just -4 times 3, or -12. Up here tells us that we're adding the terms 1 through 12, so n is going to be 12. So to find r, we're going to look at our equation. So this form should look pretty familiar to you. I know there's not n minus 1 here, but this 3 is the number that's getting multiplied more and more each time, so that 3 is your common ratio. So r would be 3. If you weren't positive, I know there's not a minus 1 here, so maybe that threw you off. What you could do is just plug in a couple of terms and then find the ratio that way. So we already knew the first term was -12. If I plugged in 2, I would get -4 times 9, which is -36, and so forth. And then if I take my second term divided by my first term, I also get 3. So if you get lost, you could always do it that way. Now that I have all of my pieces, we're just plugging back into the formula. So we're finding the sum of 12 terms, and then we're going to start with the first term, 1 minus r to the n over 1 minus r. And then we're plugging into our calculator, and that comes out to a -3,188,640. All right. So in this video, we learned the formula for a geometric series, and we learned how to use that formula to solve problems. Thanks for watching.